Hello class 7 students, welcome back to this geography class. Today we are going to start chapter 6 Air and Water. Learning objectives: Air, atmospheric layers, distribution of water, composition of air, water, tides, structure of air, water cycle, ocean current. Let's warm up. Look at the picture and answer the following questions. Fill in the blank boxes in the picture. Second, define the water cycle briefly. Application skills. The planet Earth is a very wet planet that has over 70% of its surface covered by water. Water has been on Earth for almost 4 billion years. The Earth has had almost the same amount of water now as it did almost 4 billion years ago. Most of this water is made up by the 5 oceans, which are salt water. The rest of the water takes the form of ice on the north and south poles, or found in lakes, rivers, soil, which is groundwater, and the clouds. The two types of water found on earth are either salty or fresh. The water on earth cycle between the oceans, the land, and the air, and is always on the move. As the water circulates, it changes from one state to another: solid, liquid, and gas. This continuous cycle, where water moves from the surface of the earth to the atmosphere, is called the water cycle. The water cycle is powered by the heat from the sun. Water is always on the move. Evaporation occurs when the water changes from liquid to gas. Evaporation is as though the water disappears. However, it is changing states. The liquid form is easier to see than the vapor gas form. Water vapor is the gas form of water. Condensation occurs when water changes from a gas, water vapor, to a liquid. Droplets of dew are a form of condensation. Precipitation occurs when water falls from the atmosphere to the ground. Examples of precipitation are hail, rain, sleet, and snow. Transpiration is when evaporation happens through plants. The movement of water is constant and it repeats over and over again, which is why it is referred to as the water cycle. Another name for the water cycle is the hydrological cycle. Answer the following questions. A. Identify the two types of water found on earth. B. Name 5 sources of water. C. Describe the water cycle in your own words. D. Explain what condensation, evaporation, and precipitation is. Air and water are the two most important features of earth to sustain life. The air around us forms the atmosphere. The atmosphere is like a huge blanket around the earth that protects it from various life-altering components like sun's UV ultraviolet rays. It provides us with different gases like oxygen, nitrogen, and carbon dioxide that supports different life forms on the earth. Like the atmosphere, hydrosphere is another feature of our earth that helps it maintain the living creatures on it. The hydrosphere is the water that is found on earth. The total ratio of land and water is 22% is to 71%, respectively. Water is found in seas, oceans, rivers, lakes, and gulfs, but that is salt water. Animals and humans beings need fresh water to drink and live. Only 3% of the total water is available as fresh drinking water. Our Earth is a unique planet because it supports life. No other planet has yet been discovered to have life on it. This is possible because of the atmosphere and hydrosphere. While the atmosphere saves us from the external components and provides the air to breathe, the hydrosphere provides water to drink. Let us now read more about these two components of the earth. Air. The layer that surrounds the earth is very thin. Measuring from the sea level, the earth's atmosphere reaches 10,000 km in height. The gravitational pull of the earth keeps the atmosphere intact. Its total weight is estimated at 500 million tons. The air is dense at the lower level and it becomes light and thin as we move up. This is the reason that warm air travels upwards and cold air takes its place near the surface of the earth. Composition of air. Air is composed of many gases. These gases are colorless, odorless, and tasteless. Humans and animals breathe oxygen present in the atmosphere. Plants breathe carbon dioxide and need nitrogen for their survival. The two main gas components of air are nitrogen 78% and oxygen 21%. Other gases like carbon dioxide, helium, ozone, argon, hydrogen, etc. are present in very minimal quantity, only 1%. Other components of air include dust particles, water vapor, and smoke. Water vapor and dust particles are present at the lower levels of the atmosphere, and their amount changes from place to place and time to time. The lower layers of the atmosphere are uniformly distributed by the components depending on the purity and dryness of the air. This lower layer is almost 8 km in height from the sea level. This is the pie chart of the composition of air showing 78% nitrogen, 21% oxygen and 1% carbon dioxide and other gases. Nitrogen. This gas is available in abundance. It composes 78% of the Earth's atmosphere. It is required by plants for their growth. Instead of using nitrogen directly from the atmosphere, plants absorb it from the soil with the help of bacteria. The atmospheric nitrogen is used for manufacturing chemical fertilizers. Oxygen. This gas is an essential component of the atmosphere because all forms of the life on Earth depends on this gas. We breathe oxygen from the air around us because it is a heavy gas. Plants produce oxygen during photosynthesis. They breathe in carbon dioxide and release oxygen. This helps in maintaining the balance in the ratio of the two gases. Carbon dioxide. This gas is another most important gas in our atmosphere. Plants require carbon dioxide as humans need oxygen. But in recent times, the amount of carbon dioxide has increased enormously. This has caused a greenhouse effect, GH, about which we will study in the last section of this chapter. In the loop, the site made in 1994 is spread over 36 acres. It has an accumulated legacy waste weighing 80 lakh tons. Structure of air. Based on the studies through radars and satellites, we have found that our atmosphere is made up of 5 layers. These layers prevail over one another, creating a huge blanket around the earth. Let us read about them. Troposphere. This layer has 90% of the air in it. It is closest to the earth, which means the air we breathe is present in this layer. The height of this layer is 8 km at the poles and 13 km at the equator. Its temperature decreases with an increase in height. This layer has water vapor and dust particles. It protects the surface of the earth and living organisms from direct rays and heat of the sun. All the weather phenomena like rainfall, thunder, lightning, cloud formation, etc. occur in this layer only. Stratosphere. This layer lies above the troposphere. Its estimated height is 50 km above the sea level. No clouds and other weather phenomena occur in this layer. Its temperature remains constant for 20 km and then increases with increase in height. The lower level of this layer is known as the ozonosphere because of the presence of ozone in concentrated amounts. Its height varies from 15 to 35 km. The ozone protects the earth from UV rays of the sun reaching directly to the surface, saving the living organisms present on earth. Jet airplanes fly in this layer. Mesosphere. It lies above the stratosphere and extends from 50 to 80 km in height. It is the coldest layer in the atmosphere and its temperature decreases with height. The temperature reaches minus 100 degrees Celsius. Meteors and other rocky objects coming from the space burn in this layer. Thermosphere. This layer lies above the mesosphere and reaches the height of 400 km from the sea level. The temperature increases with increase in height, reaching 1500 degrees Celsius. The lower part of the layer carries ionized molecules and is known as the ionosphere. Radio waves are reflected in this layer as they are low frequency waves and helps in wireless transmission that merges into the outer space. This layer contains gases like hydrogen and helium. Therefore, its temperature reaches 4500 degrees Celsius and increase with increase in height. Fact file. Oxygen is a heavy gas. Therefore, it is present in the lower level of atmosphere. This is the reason when mountaineers climb mountains or skydivers dive from the sky, they need to carry oxygen cylinders with them. Atmospheric layers, greenhouse effect and global warming. The term greenhouse basically means a glass room used for growing plants in cold regions. This works through the glass walls into the chamber and the environment inside the glass chamber increases. During the night, this captured heat keeps the temperature warm, letting the plants grow at their natural pace. The same phenomenon is used on Earth. Carbon dioxide absorbs the heat of the sun and does not allow it to escape at night, thus keeping the Earth's temperature warm. This effect is called greenhouse effect. But with technology, population advancement and deforestation, the amount of carbon dioxide has increased at an alarming rate. The increased amount of carbon dioxide absorbs more heat and the average temperature of the Earth increases. The rise in the Earth's atmosphere is called global warming. Given below are some observations on global warming. The concentration of carbon dioxide has been recorded the most in the last year in the past millennium. The glaciers are retreating, ice sheets are losing tons of ice every year, and snow-covered lands have less snow every year as observed by the satellites. Sea levels are increasing slightly every year due to melted ice joining the water bodies in huge amounts. 11% of the human population is breathing concentrated air affecting their health. Water, just as the air around us is known as atmosphere, the water around us is known as hydrosphere. Fact file. In the past decade, the occurrence of high temperature events have been recorded more than cold temperature events. The US experienced the warmest winters ever in the year 2018. Polar bears and other Arctic animals are facing starvation and other living hardships that may result in the extinction. The water covers 71% of the total Earth's surface, exerting its dominance over the land. It is estimated that the Earth's surface carries about 1250 million cubic kilometers of water. Its amount is said to be fixed. It has a great capacity to absorb heat. Therefore, the circulation of water helps in regulating temperature. Water is one of the most essential components for the survival of all living organisms on Earth. Water cycle. Water has been there on Earth since the Ice Age. Its amount has not changed much since then. This means that the water on Earth keeps on circulating continuously in one form or the other. The circulation of water is known as water cycle. The water cycle is a process in which water circulates on the Earth through the process of evaporation, condensation and precipitation. The water in water bodies and moist land evaporates with the heat of the sun. This is the picture explaining the water cycle. Moving up in the air, the evaporated water condenses and forms clouds of water droplets, resulting in the formation of clouds. When these clouds get heavy, precipitation happens in the form of rain and snowfall. The evaporated water is then brought back into the rivers and oceans. This is a never-ending cycle and is known as the hydrological cycle. Fact file. The water on the Dead Sea near Israel is so saline that its density allows the swimmer to float in it. It is said to be 340 gram per liter. In this map, you can see the distribution of water supply around the world. Most of the water present on Earth is not fit for drinking. 97% of the total water is ocean water and has salt and other minerals like sodium chloride and table salt that make the water impure for drinking. This water is called saline water, and the amount of salt present in the water in a particular amount, that is 1000 gram at a particular time, is called the salinity of the water. The average salinity is 35 parts per 1000 gram, but it varies from ocean to ocean. Only 3% of the water is pure and fit for drinking. It is provided only by rivers, ponds, lakes, and glaciers. Distribution of water. Oceans are the largest water bodies present on the earth. They contain almost all the water. Given below is a world map that shows the distribution of water in the oceans. The oceanic water is divided into 5 oceans, namely Atlantic Ocean, Arctic Ocean, Indian Ocean, Antarctic Ocean, and the Pacific Ocean. The water in these oceans cover 97% of the total water as discussed above. The Pacific Ocean is the largest ocean in the world. The Antarctic Ocean is basically called the Southern Ocean. Fact file. Water is the only component that can quench our thirst. Besides so many other drinking alternatives, therefore, it has become a worldwide phenomenon to save water for ourselves, our coming as well as our coming generations. Circulation of oceanic water. The ocean water, unlike water in ponds and lakes, is not still. It keeps on moving. This movement of ocean water is called the circulation of ocean water. It moves both horizontally and vertically. These horizontal and vertical movements are termed as waves and tides, respectively. There are certain factors responsible for these movements. For example, winds, temperature, salinity, and density of ocean waters. Think smarter. Abhi inflated 4 balloons as shown below. What property of air can he prove from the above figures? A. Air has matter. B. Air has mass. C. Air occupies space. D. Air has no weight. Let us read about them. Waves. The horizontal movement of the ocean water is known as waves. When the wind blows across the surface of the water, it rises and falls. The water movement is limited, but the waves travel great distances depending on the wind. This is the reason why the objects like ball come back to the shore when thrown in the ocean. The speed of the wind directly affects the size and shape of the wave. Crest and troughs are the rise and fall of the wave respectively. Wavelength is the distance covered by one rise or fall to another. Wave height is the vertical measurement of the wave. When a strong wind blows, it often leads to high waves. These waves can take a disastrous form and can bring devastation on the shores. Sometimes occurrences on the seabed like earthquakes or shifting of plates causes movement of water in large amount. This is then followed by tidal waves and results in the waves' great heights. Such a calamity is very dangerous and causes damage to life and property. These waves are known as tsunami. Fact file. Tsunami is a Japanese word which means harbor waves. It is pronounced as tsunami. The waves were named so because they wash away the harbors. Tides. Tides are alternative rise and fall of sea level twice a day. It happens every day twice and at an equal interval. A tide is said to be high when the water level reaches its highest point, and the tide is said to be low when the water level is lowest and it starts receding from the shore. Tides are the result of the gravitational pull of the moon and the sun. The moon being closer to the earth as compared to the sun has more effect on the tides. The event happens twice a day and with different height at both times. Spring tides are the high tides as a result of the full moon and new moon. This is because the sun and the moon and the earth are aligned in the same configuration. During the half moon, the tides are the lowest. This is because the gravitational pull of the moon and the sun coincide with each other because of low tide, which are called the neap tides. In this picture, you can see high and low tides. Tides are very important in nature. Some of the important aspects of tides are discussed below. High tides are used by mariners at the port. The water levels at the port increases during high tide and it helps the ship to reach safely and closer to the port. High tide brings fishes near the shores. It helps fishermen and other fishing companies. Saline water recedes to low-lying coastal areas. This water is later evaporated and common salt is manufactured. Countries like UK, Japan, France and Canada have tidal power stations that uses high tides to produce electricity. Wave and tides are the two movements of ocean water. There is another movement known as ocean current that prevails in oceans. In this picture, you can see salt fields and in the second one you can see tidal power station in the UK. Ocean current. Ocean current is a definite movement of ocean water in a definite direction. The ocean water moves from one ocean to another. The ocean with warm ocean current moves towards the cold ocean and vice versa. The temperature of the current determines the temperature of the nearby land. The current near the equator are warmer than the currents near poles. If direction of the northern hemisphere oceans is clockwise, then the southern hemisphere experiences an anti-clockwise direction. In this map, you can see the ocean currents of the world. Case study: Tsunami in 2004. On December 26, 2004, the world witnessed one of the third biggest earthquakes that have ever happened in hundreds of years. It took place in the Indian Ocean and had a magnitude of 9 on the Richter scale. Its epicenter was the western boundary of Sumatra. The Indian plate was displaced up to 20 meters and went under the Burma plate. This displacement was created in a downward direction. The water filled the gap and the coastlines of South and Southeast Asia started to decline. When plates adjusted themselves, the filled water seeped out of the gaps and formed huge waves. Reaching the coastlines, a tsunami at the speed of 800 km per hour rushed towards the shores, engulfing several small islands in the Indian Ocean. Andaman and Nicobar Island saw complete submerging of the Indra Point, the southernmost point of India. The wave height reached 20 meters and travelled 3 kilometers inside the coast, killing thousands of people, and property loss was unaccounted. The coastal areas of Puducherry, Andhra Pradesh, Tamil Nadu, Kerala and Andaman and Nicobar Islands were the affected regions in India. Other countries like Indonesia, Sri Lanka, Thailand and some others on the east coast of Africa saw the devastation of their seashores. The destruction in India was far more than it could perhaps ever recover. Value and life skills. When a natural calamity or disaster hits a part of the earth, loss of the life and property depends on the intensity of the disaster. We, as an ideal citizen, should always come to the aid of the affected people. Aid like donation of clothes, money, food, or even volunteering can provide great relief to the affected people. At the time of need, we must unite together under the name of humanity and help each other. Recapitulation. The air around us forms the atmosphere. The hydrosphere is the water that is found on Earth. The two main gas components of air are nitrogen 78% and oxygen 21%. Other gases like carbon dioxide, helium, ozone, argon, hydrogen, etc. are also present in very minimal quantity. Only 1%. The water covers 71% of the total Earth's surface, exerting its dominance over the land. Water cycle is a process in which water circulates on the earth through the process of evaporation, condensation and precipitation. The never-ending cycle of water is known as the hydrological cycle. The oceanic water is divided into 5 oceans: Atlantic Ocean, Arctic Ocean, Indian Ocean, Antarctic Ocean and Pacific Ocean. These horizontal movements and vertical movements are termed as waves and tides respectively. When the wind blows across the surface of the water, it rises and falls. Crest and troughs are the rise and fall of a wave respectively. Tides are alternative rise and fall of sea level twice a day. Tides are the result of the gravitational pull of the moon and the sun. Spring tides are the high tides as the result of the full moon and new moon. Ocean currents is the definite movement of ocean water in a definite direction. Carbon dioxide absorbs the heat from the sun and does not allow it to escape at night, thus keeping the Earth's temperature warm. This effect is called the greenhouse effect. Thank you, class. Let's meet again in the next chapter.